This is examples of music for Module 57. 57.1 says define a 12-tone row and label rows after applying the operations of transposition, inversion, retrograde, and retrograde inversion. Let's listen to this short work by Finney, and then we'll do some analysis. A 12-tone row is an ordered segment that consists of all 12 distinct pitches. Some serial music is composed with these 12 pitch class segments. These compositions are called 12-tone music, or sometimes called dodecaphonic music. The piece we just heard is a simple representation of 12-tone music. The piece starts off in octaves, playing the same pitch classes in the upper and lower voice. If we analyze these pitches closely, we find the following: 9, T, 8, 7, 5, 6, 3, 4, 0, 1, E, 2. The piece goes through all 12 pitches before ever repeating any one of them. This 12-tone segment fits our definition that we learned from a previous module, enabling us to label it the prime form. A prime form of a segment is the first full appearance of the segment in the order in which each pitch appears. The operations involved in Objective 57.1 are transpose, retrograde, inversion, and retrograde inversion. All of these were introduced in a previous module, and they are the same here, except instead of applying it to a set of limited pitches, we're applying it to an entire 12-tone row. For transposing a row, we choose or are given a transposition number, and then we add that number of half steps to each integer. For example, if we wanted to transpose by 4, we would add 4 to each of these. 9 plus 4 is 1, T plus 4 is 2, 8 plus 4 is 0, 7 plus 4 is 11, 5 plus 4 is 9, and so on. 6 becomes T, 3 becomes 7, 4 becomes 8, 0 becomes 4, 1 becomes 5, E becomes 3, and 2 becomes 6. This is a transposed version of the prime 12-tone row. For retrograde, we take the original prime form of the row and simply reverse everything. The retrograde reads forward as the prime does backwards. 2, 2, E, E, 1, 1, 0, 0, 4, 4, and so on. To obtain an inversion relationship to the prime form, we can do a direct inversion like so. 9 inverts to 3, T inverts to 2, 8 inverts to 4, 7, 5, 5, 7, 6, 6, 3, 9, 4, 8, 0, 0, 1, E, E, 1, 2, T. In the case of this piece, as well as the self-assessments and quizzes involved in this objective, when we ask for the inversion of the prime, we want you to start on the same pitch that the prime starts. Since our direct inversion starts on 3, we will need to transpose this entire direct inversion so that the first number is 9. I'm going to add 6 to 3 to get the first note to 9, and therefore add 6 to all the rest of them. The result is this: 9, 8, T, E, 1, 0, 3, 2, 6, 5, 7, 4. That row is an inversion to the prime form. Finally, the retrograde inversion. To obtain the retrograde inversion, first find the inversion and then list that in reverse order. We ended with 4, we'll start with 4. Then 7, 7, 5, 5, 6, 6, 2, 2, and so on. This is called the retrograde inversion. Remember, when you're finding the retrograde inversion of a prime form, make sure you invert it first, do a transposition if needed, and then do the retrograde. So back to our analysis of the opening tone row, here is the prime form in blue. The piece remains in octaves between the right and left hand, so we have the same pitch classes going on in the upper and lower voice. We now want to look for what form the row appears in this area. There are 12 distinct pitches in the blue box, and if we count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's only 11 pitches in the next little segment. When we see these notes in this cluster, we'll notice that those have already appeared before we have reached all 12 distinct pitches. This piece is a unique setting where the last note of the opening row also serves as the first of the next row. So we're actually going to count that as our first note in this grouping of pitches. If we convert these to integer form, we find that we have 2, E, 1, 0, 4, 3, 6, 5, 7, 8, T, 9. If we look at our options down here, we'll notice that those numbers line up exactly with the retrograde form, and we would label that section the retrograde of the original prime form 12-tone row. As a bit of bonus information, theorists sometimes label prime form of a 12-tone row with what are called order numbers. Order numbers are just labels of 1 through 12. They're designating which exact pitch comes at which time. The order number for integer number 3 comes 7. It's the 7th place in the order of the 12-tone row. In this case, if we labeled the prime pitches with order numbers, they would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we labeled the retrograde pitches, they would be the reverse. They'd be 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Order numbers are particularly helpful when we have 12-tone pitches appearing as clusters or harmonically. In this case, we can see that the prime form of the row appears again in a way that resembles the original order of the 12-tone row. Order number 1 appears here, 2, 3, 4, 5 all appear as this chord, 6, 7, 8, 9 appear as this chord, and 10, 11, 12 appear as this chord. Objective 57.2 says, construct a row matrix given a 12-tone row. This is a famous work by Luigi Dalla Piccola. Let's listen and then do some analysis. This piece opens presenting us with a 12-tone row. I'm going to zoom into this section. The first 12 pitches are the prime form of our 12-tone row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those pitches translate into integer notation as 8, 9, 7, 5, E, 4, 2, 3, T, 1, 0, 6. When we've determined the order of a row, we can create something called a row matrix, which will display all possible transpositions, all retrogrades, all inversions, and all retrograde inversions. There are a couple of different approaches to this. What we are going to first do is take our known row and we're going to transpose it so that the first integer is 0. In this case, we can either add 4 to 8 to get 0 or subtract 8 from 8 to get 0. Either way, do the same to all the rest of the integers, and we would result with this: 0, 1e, 9, 3, 8, 6, 7, 2, 5, 4, t. This will be the first horizontal line of our row matrix. Here we have a 12 by 12 grid, and we have extra boxes surrounding it that we'll use to make labels later. Inside the first horizontal line, we have the prime form of the row transposed so that the first integer is 0. The next step in creating the row matrix is to make a vertical line going down. The numbers that go in this first vertical column will be the inverse of the numbers that go to the right horizontally in this row. The inverse of 0 is 0. The inverse of 1 is E. The inverse of E is 1. The inverse of 9 is 3. The inverse of this 3 is 9. The inverse of 8 is 4. The inverse of 6 is 6. The inverse of 7 is 5. The inverse of 2 is t. The inverse of 5 is 7. The inverse of 4 is 8. And the inverse of this t is 2. Now we'll fill in all the rest of the horizontal rows in this manner. This row will start with E. That is a transposition of plus 11, or you could get there by going minus 1. Do either of those calculations to the rest of the numbers in this row and put your answers here. 1 would become 0, E to T, 9 to 8, 3 to 2, 8 to 7, 6 to 5, 7 to 6, 2 to 1, 5 to 4, 4 to 3, T to 9. For this row, the number is 1. Compared to 0, that's a plus 1, so let's do plus 1 to all of the numbers in this row. We'd come up with this. Here we have a transposition from 0 of 3. The next row we have a transposition of 9 with the top row. Then a transposition of 4 with the top row, a transposition of 6 with the top row, a transposition of 5 with the top row, transposition of t with the top row, 10, a transposition of 7 with the top row, a transposition of 8 with the top row, and finally a transposition of 2 with the top row. We now have a complete row matrix. When reading rows of left to right, those are all transpositions of the prime row. When reading rows backwards from right to left, that will give us all of the possible retrogrades of the prime row. When reading notes from top to bottom, that'll give us all possible inversions of the prime row. And when reading rows from bottom to top, that will give us all possible retrograde inversions of the prime row. If we created our row matrix correctly, we should be able to find this 12-tone row within it. 897, 5E4, 23T, 106. And here it is. 897, 5E4, 23T, 106. Objective 57.3 says identify the contents of a row matrix given its row matrix label. In our previous objective, we learned how to construct a row matrix. We also said that reading from left to right gives you transpositions, reading from right to left gives you retrogrades, reading from top to bottom gives you inversions, and reading from bottom to top gives you retrograde inversions. Each of these forms of the row can be referred to by labels, which appear like this. When reading a row from left to right, it is assigned a letter of P, or prime. And it also has a number that consists with what is the first integer of the row, in this case the leftmost box. So our row that appears in the piece starts with the number 8. It's the prime form of the row, and we would label it P8. Here's our P8 row. Let's look at the next section of the piece. We'll analyze them in integer notation. In order to do this correctly, we have to take a little bit of liberty and leeway. The first three notes are 9, 8, T, and then you'll see the 9 and 8 repeat. We're not going to count those in this case. So we have 9, 8, T, then 0, 6, 1, 3, 2, 7, 4, 5, E. We're going to go back to our matrix and look for 9, 8, T, 0, 6, 1, 3, 2, 7, 4, 5, E. That row could go horizontally, backwards, down, or up. Since the first integers are 9, 8, T, let's look for that. Here we start with 9. We have 9, T, 8, which is not correct. We look for 9 here, we have 9, 3, 2, not what we're looking for. The first 9 here would be 9, 3, 4, nope. And then here is 9, 8, T. That's correct. Let's make sure the others are correct as well. 0, 6, 1, 0, 6, 1, 3, 2, 7, 3, 2, 7, 4, 5, E, 4, 5, E. This is the next row that appears in the piece. It is an inversion of the prime form, and since it starts with the number 9, it gets the label I9. So we'd go back to our piece and label that section I9. A couple other things about labels on a row matrix. For the P numbers, the transpositions, we read from left to right. It's labeled with a P plus the first number. So this is P9, this is P5, this is P7. For the inversions, we read it from top to bottom. It's labeled with an I letter and whatever is the first number. This row is I8, this row is I7, this row is I1, this row is I5. For the retrogrades, we label it with an R letter, and the number is whatever was the first number over here. It's the first number of the row left to right, or if you're reading it in retrograde, it would be the last number read of the retrograde. So this row is R0. This row is R9. This row is R5. This row is R7. And for the retrograde inversion, we read it in the order from bottom to top, and we label it with RI, and the number comes from the top box in the row matrix, or what would be read as the last number in the retrograde inversion. This retrograde inversion is RI9. This is RI5. This is RI1. This is RIT. I'd like to give you a little bit of bonus information concerning 12-tone music. This is the waltz from Schoenberg's Klavierstück, and it's considered one of the first, if not the first, 12-tone row composition. Let's listen for a bit and then we'll do some analysis. This piece was composed based on a 12-tone row. Sometimes it's not as easy as our very first example. In our previous examples of Module 57, the prime form in the row was introduced pretty clearly. In this example, it's a little bit more difficult. When we're taking account for all the pitches, we might not be sure if we're supposed to read just the right hand, the upper voice, or if we should count the first note plus the notes in this cluster chord of the top and bottom voices as we go along. Either way could be true, but we're not sure just from looking at the piece right away. If the tone row is used in a consistent manner, even if it's put in transposition, inversion, retrograde, or retrograde inversion, we can sometimes find snippets of the row in different segments of the piece to deconstruct and then reconstruct what the prime form in the row is. To do this, one strategy is to find sections where notes are laid out melodically and not harmonically. For example, here are two sections. We have melodic intervals here, and then we have melodic intervals here, all played independently and not at the same time. The next section where that occurs is over here on this page, these melodic notes and this last one. We have three segments of melodic pitches, but these may not be from the same occurrence of the tone row. But if the tone row is used consistently, we might be able to use some logical thinking to determine what the full row is. In integer notation, we have 4, 3, 0, 5 in this segment. We have 6, T, 2, 4, 3 in this segment. And then we have 19E786T243 in this segment. If we can find some similarities of order, then that will confirm to us that is part of a consistent row order. Here we have 4305. There are two common pitches between this segment and this segment. They are the 4 and the 3, and they appear in the same order. 3 appears after 4, 3 appears after 4. So that gives us a clue that 4 and 3 appear in that order of the row. Here we have a great rendition. Again, we have 4 and 3 appearing one after the other. In addition, we have 6T2 appearing before 4 and 3, as we do here, which matches up with this segment, 6T243. We also have the numbers 19E78. In this segment, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pitches, and we're only missing 2, the 0 and the 5. If we take that segment and put it here, and realize that we have 4, 3, and 4, 3 up in this first segment, we can take the 0 and 5 from the first segment and put it down here, and come to a pretty good theory that the prime form of the row is 19E786T24305. Let's match up these numbers with some order numbers of 1 through 12. Now that we know what we're looking for, we can see that in the upper voice, the row does appear in order. Here's the first note, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, and 12th note of the tone row. So let's use the order numbers to label these down here. Here we actually have the same pitches in the same order, but what's unique about this is that instead of being a transposition and inversion or retrograde inversion, it's the same prime form of the row, but starting with order number 6 instead of order number 1. This cluster is made up of 6, 7, 8, then 9, 10, then this cluster is made up of 11, 12, and then after 12 it flips over to 1 being there as well, then 2, then the final 3, 4, and pitch 5. This is a particularly good example to use order numbers on, because let's look at the next segment. Here, Schoenberg puts the 9 a little bit early, but we have 6, 7, 8, 9, 10 basically grouped together, then 11, 12, 1, 2, and then 3, 4, 5. The next segment, again, starting on 6, 6, 7, 8, 9, 10, 11, 12, then 1, 2, 3, 4, 5 in terms of order numbers.